Okay, what we're going to look at now is how to calculate a gradient. So sometimes what you'll be given is you'll get some sort of slope. Okay, quite often it's a story about a road going up a hill or some sort of ski place where there's a slope that people are skiing down, something like that. Okay, and you know that a slope, some sort of hill or whatever, is going to have a shape like this. Okay, so we have a slope. All right, now typically that hill or whatever has some sort of horizontal distance. Okay, so there's always some sort of horizontal distance happening with this hill, and there's also always some sort of vertical distance. Okay, so here we have a slope, and you can see that we're able to make this into a right-angled triangle. Now, when you have these slopes, what you've learned in the past, you've actually learned how to calculate the gradient of a line before. And what you learned is gradient is equal to rise over run. So this is what you learned in the second year, and it's also what we use for calculating gradients even when it's just a hill or something. Okay, so we still use the rise over the run. Remember, rise means to go up. So we have a rise here, that's the vertical distance, and the run, if you run horizontally usually. Okay, so a run means to go horizontally. So when we're calculating the gradient of a slope, of a mountain, of a ski slope, of a road, we use the same formula as you've used when you've calculated the gradient of a line in a coordinate plane. So you still do gradient equals rise over run. Now, yeah, there's not really that much more to it at this point. So what we could have is that you will get a question where you're given, a slope. Okay, I'm going to go straight to drawing a triangle here. Let's draw it like this because I want to make this a little bit more realistic, because usually they're quite long slopes. Okay, the bottom's still not horizontal, but fine, let's pretend it is. So let's say that we've got a road, and the road increases in altitude from an altitude of 100 meters up to an altitude of 1200 meters. Okay, so that's the altitude change from the bottom to the top of this road. Okay, let's say that horizontally we know that the distance from the start to the end is 2 kilometers. Okay, so in a horizontal distance of 2 kilometers, the road climbs from an altitude of 100 to 1200 meters. And we would like to know the gradient of this road. Okay, so the first thing you do is you will need to calculate the actual vertical displacement. So you're going to need to calculate how high this road has gone over here on the right. All right, that's pretty easy because you've got 1200 meters minus 100 meters, which leaves you with 1100 meters. Now the horizontal displacement here, the horizontal distance is 2 kilometers. We shouldn't be mixing units. Okay, so instead of 2 kilometers, we're going to write this as 2000 meters. All right, it would have also been fine for you to write 1.1 kilometers and keep it in kilometers, but yeah, I prefer to go with meters here. Now, the gradient of this road is equal to the rise over the run. Okay, and again, rise, if you ask someone to rise, they stand up. So the rise is 1100 meters and the run is 2000. Okay, and this is going to give us our gradient. 1100 divided by 2000, we get 0.55. So that means the gradient of this road is 0.55. Now, some of the questions are going to talk to you about grade instead. Grade. Grade is gradient expressed as a percentage. Okay, so if you had here a gradient of 0.55, if you want to express that as a percentage, the grade here is equal to 55%. Okay, so all you have to do to go from gradient to grade is multiply by 100. Okay, if you want to go from grade back to gradient, so say you're given a grade and you're asked to do something with the gradient, then you have to divide by 100. Okay, now alternatively, you also might get given the question in the other format. So let's say that we get given, again, that there's a lovely road. So let's see if I can do this a bit better this time. Let's say that we've got a lovely road like this one. Oh, not very well drawn. Okay, we've got this road. Again, pretend that bottom is actually flat. It's a little hard to draw them. So we've got this road. We know that the altitude change is from 635 meters up to 3,423 meters. I don't know, I'm just making something up. And we know that the grade of the road is equal to 23%. Okay, and the place you'll see, the usual place where you'll see these grade signs is actually on roads. So quite often in the mountains, you'll see a little sign on the road and it will tell you the grade. Okay, and that's to indicate to, mostly to trucks, that it is quite a steep road. Okay, it means if it's a high percentage of grade, it means it's quite steep and they need to be aware of, you know, being more careful with the speed and worrying about their brakes and things. So let's say we've got this, and the question is, what is the horizontal distance of this road? What is the horizontal distance that they have traveled along this road? So this is one where we need to work backwards. Now we're going from grade to gradient, okay? So as we said here above, if you're going from grade to gradient, you need to divide by 100. Okay, so we're going to do that first. So we know here that our gradient is 23 divided by 100, which gives us 0.23. So that is the gradient of this road. Now again, we know the gradient is equal to rise over run. Both of these things here, both 0.23 and the rise over the run, are equal to the gradient. So that means they're equal to each other. So we know that the rise over the run is equal to 0.23. Okay? Now, we don't know the run. The run is what we're trying to calculate. This here is the run. So we know that we can put an x there. Okay? 0.23. We need to calculate our rise. Our rise is 3423 minus 635. So 3423 minus 635, and that gives us 2788. So 2788. Okay. Now again, these questions now are like the questions about solving equations that have a fraction in them. Okay, that's what we did in the last video. And as usual, you have a denominator, and the best strategy here is we're going to multiply by the denominator. So x times on both sides. Okay, the left side here, the x's cancel out. So we get 2,788 is equal to 0.23x. The next step, we want to get x by itself. So we know that we're going to need to divide both sides. I'll write it down this time by 0.23. I'm going to now write the x on the left because that's where it should be at the end anyway. So we get x is equal to 2788 divided by 0.23. So 2788 divided by 0.23. So 12121.73. Now, 2 decimal places is the usual rounding, so it's 0.74. So 12121.74. Okay, now go back to the start and have a look. This is in meters. Okay, so we need to make sure we add that to our answer here. And usually I do always say to you that if you've answered a question that has a bit of a story, that has a bit of context, this is a story about a road, okay, then we need to write that the horizontal distance is 12,121.74 meters. Now, typically, if it was numbers like this, we would probably actually ask you to round to integers, to whole numbers. So actually, I would probably have 12,122 as my answer, but let's just go with this for now. That's really it. So we've done 2 versions of this. We've looked at it in both directions. That should give you a bit of an idea of how this works.